Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question.
Yeah, today's question is really maximum. In this question, given an array E of n listing element, so focus on this per listing, and we're asked to perform the following operation as many times as we want on an array E, while the size of array is greater than 1. So we can choose a continuous subarray of size exactly n minus 1, where n is the current size of the array, and then delete the maximum element from the subarray from like the original array. Now note that the maximum element is unique because all the elements are distinct and that decreases the size of it by exactly one in every one. So what are we given? When given some elements A1, A3, dot, A of n, we can either choose these first n minus 1 elements or choose the last n minus 1 elements and delete the maximum element from this array. And when given that this array would be like this maximum element would be unique because all the elements in the array are distinct and they're between 1 and n. So essentially, we can say that A is nothing but a computation of the numbers from 1 to n, right? Now we need to find the number of arrays that can be formed by the process modulo this number. So this is pretty much the whole question. It will be more clear once we see the sample inputs. But before that, let's see the constraints once. So we are given that the number of test cases will lie in between 1 and 10 raised to the power 4. N will lie between 2 and 2 into 10 raised to the power 5, and A of I will lie between 1 and n. No two elements are same, so all the elements are distinct. And we're also given that sum of n over all the test cases does not exceed 2 into 10 raised to the power 5. Now let's see the sample input ones. So in the first sample input, we are given two elements, 2 and 1. And the three possible arrays that we can get is we choose this subarray of size n minus 1 and get 1 as our final array. Or we choose this subarray and remove the maximum that is 1 and get this 2 as our array. So in total, we can get three number of different arrays. Another possible example is this 3142. So what we can do is we can choose, like either choose this subarray and remove this 4, or we can choose this subarray and remove this 4. So because this is a bit long, over here it will be 3, 1 and 2. Now we have two options again. Either we can choose this subvariant 3 or we can choose this subvariant 2. So we'll be getting either a 1 and 2. If we remove this 3, or we'll be getting 1 and 3. Ultimately, we'll be getting 1, 2, and 3 as our final possible arrays. So these are the seven possible arrays that we can get, right? Now in the last, we have 1, 2, 3. So one possible option is remove this 3 and we'll be having this 1, 2. And then remove this 2 and then we'll be having this 1, or remove this 1 and we'll be having this 2. Or we can choose this summary and this 2 and we'll be getting this 1, 3. Then remove this 1 and we'll be getting this 3. So in total, we can get these 6 arrays, which is the answer, right? So this is pretty much the problem statement. Now let's move to the solution. So see, for the very first step is, let's say we're given some n elements like this, right? Now we can either choose these n minus 1 elements, right? Or we can choose these n minus 1 elements, right? Now what if the maximum elements lies in between some, right? Over here there is some maximum element, right? This maximum element will be removed irrespective of what operation we do, right? So even if we like apply the operation on this much array or this much array, this maximum element is what is going to be removed, right? So we do not have any freedom. This maximum element will ultimately be removed, right? So if the maximum element is in between this A2 here and minus 1, then irrespective of what we do, this maximum element will be removed. So we'll not be getting any new information. And what do I mean by new information? So obviously, trivially, we can have an array, right? So if we have, let's say, one, three, four elements, then one very trivial case is we remove this 4, then remove this 3, then remove this 2. And the four possible arrays that we are going to get is 1, 2, 3, 4. 1, 2, 3, 1, 2, and then 1, right? These four elements were always trivially manipulated, right? Irrespective of like what we do. Like we can always remove the largest element and these elements will be getting right. So we are not gonna get any new information or any new array if we are gonna remove this max element, right? And there's no other option in this case. Now, when do we have an option? When do we have a choice? That is when the maximum element is either a of 1 or a of n, right? So when do we have a choice? If the maximum element is a of 1 or a of n, right? So for example, if this is our array 8 4 5 6 3 2 1 7, then we have the option, right? So either we remove this element 8 if we choose this array, or we remove this element 7 if we choose this array, right? So we have some options to create some new arrays, right? In this case. Now what do we do? So we have an option to remove this 8 or not remove this 8, right? So what happens if we do not remove this 8 and later on remove this 8, right? Let's see what happens. So we have not removed 8, so we remove this 7. So 8 4 5 6 3 2 1 7. Now this 7 is removed. The 7 does not exist. And in the next operation, I remove this 8. I'm gonna get this n, right? Now what if I had removed this 8 earlier and then I remove this? So I had this 8 4 5 6 3 1 7. I remove this 8 and now I remove this 7. I'm gonna get the exact same error, right? I'm not gonna get any new information or any new possible error, right? So can we say that if either we remove the largest element, like either we never remove it or we remove it immediately? Now, what do I mean by that? So because I remove the 7 and then I remove this 8, I'm not gonna get any new information. So it's always better that either you just remove this 8 right now and just try to get how many possible new errors you can get from this much part, or just do not remove this 8 at all, right? So if this 8 is fixed, we're not gonna remove this 8. Then what's gonna happen? We'll be removing the 7, right? In the first one, we'll be removing the 7. So we'll be getting another array that is this one. Then we'll be removing another element, which is the 6. So this 6 will be removed, and we'll get another array. Then this 5 will be removed, and we'll be getting another array, which is this 8 4 3 2 1, right? Then this 4 will be removed. We're going to get another array. Now we're not removing this 8, right? Because if we remove this 8, we could have like in like very at the beginning remove this 8 and then done the XOR operation, and we would have got the exact same as, right? So it's just pretty useless to remove this 8 at this point. Now another option, we remove this 7 and we'll remove this 3 and we'll get another possible array. We'll remove this 2 and we'll get another possible array. And if we remove this 1 and we'll get another possible array, right? So we can get in total this 8 minus 1, or if we are removing n the element m, then we're going to get m minus 1 possible arrays, right? Right. So in total, we'll be getting n minus 1 elements. If we do not remove this 8, or if we remove this 8, we can just count how many arrays, like how many different arrays we can get in the leftover one, right? And that is how we can simply calculate the total number of arrays. So if we just formalize this algorithm, so what are we doing? We'll keep deleting the largest element, right? Why the largest element? Because obviously, like either irrespective of what we do, we'll be either like deleting this much part or this much part, right? So we have two options. Either like remove this largest point and we'll be adding at my like what do we have? If if we're not removing this 8 right now, we can add m minus 1 to our answer, right? So initially our answer is n because we can get n arrays of this. And if we're removing this, we're not removing this 8, we're choosing to keep it, then we'll have to remove all of these numbers one by one and we'll be having m minus 1 new arrays. Or the other option is just remove this 8 and count how many can we get in this much, right? Now let's see what are the algorithms. So we'll be obviously like keep deleting the largest element m, right? Now if my current m is the largest point on either of the endpoints, right? If it is like largest endpoint, then we can add m minus 1 to our answer. Otherwise, we are not going to get m given for, right? Why? Because let's say we had 6, 3, 5, 4, 2, 1, and 7. 7 is let's say here. Now, either we remove this part or if we choose this part, the 7 will be removed ultimately, right? So if this largest point m is not on any of the endpoints, we are not going to add anything because it's not going to give us any possible error, right? Otherwise, we'll be simply adding m minus 1 because Keeping this point fixed and removing all the other elements one by one will give us n minus one new possible points, right? New possible errors. So let's see on this. So let's say we have some array like this, right? So initially we'll start from 7. So this 7 is already possible answer. That is, we always just keep on removing the largest element. Now, this 7 is our largest element and it is on one of the endpoints, right? So what can I do? I can keep this 7 as fixed and I can keep moving this 6 first, then this 5, then 4, then this 3, then this 2, and then this 2, right? So I can add 6 possible new arrays, right? Now this 7 is removed. Now is this, what is the next largest element? The 6. Now is this 6 on any of the endpoints? Yes, it is. So I can keep this 6 fixed and keep removing this 5, 4, 3, 2, and 1. And I can add 5 new possible arrays that I can get. Now what are those 5 possible arrays? The 6 is fixed. 5, 4, 3, 1. This was the initial array. So this is the first possible array. Second possible array. Third possible array. Fourth. And the fifth possible array that we can get. Right. Now this 6 is also removed. Now what is the next largest point? 5. Is it on any of the endpoints? No. So I'll be adding 0 for it. Why? Because this will ultimately get rid irrespective of what we do. Now what is the next largest element? 4. Now this will also give us a contribution of 0. Now what is the next largest element? 3. Is it on any of the endpoints? Yes, it is. So we'll be adding for it. Now the next element is 2. Is it on any of the endpoints? Yes, it is. So we'll be adding 1. And next it is 1, so it will be obviously 0. Now, what is the total number of array we can get? 7 plus 6 plus 5 plus 2 plus 1, which is 20, which is the answer for this particular case. And this is how we can do this question. Now, one warning or disclaimer is that we need to print it modulo this number m. So just don't forget to take the modulo with the final answer. Now, one more thing. How do we check if a particular m is on the endpoint or not, right? So how do I check it efficiently? So how do I check if 7 is on the endpoints of the elements remaining from 1 to 3 dot 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 7, right? How do I check them? Right. So let's say I need to check for 6. Is my 6 on any of the endpoints or not? So I'll store the positions of all of these elements inside this position array. And then what we'll do is, if the position of m is min of is equal to the min of position of 1 2 dot 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 m, then that means it is the left endpoint out of the remaining ones, right? Now what are we doing? We know that all the points greater than m are already removed, and the remaining points that I have is in between 1 to m, right? Now, if the position of m is the lowest among all of these remaining points, that means this m is the left endpoint. And similarly, if position of m is the maximum among all of the remaining points, that means m is on the right end, right? And this way, we can just recompute all of these values as prefix sums, prefix minimums and prefix maximums. So brief max and brief minis. And then we can simply just calculate all of these in constant time. And if it is any of the endpoint, we'll add a minus one to our answer. Otherwise, we'll not do anything. This is pretty much the whole solution, which will run in a time complexity of big O of n, which will easily match all the test cases. So now let's the solution in C++ first. So we'll begin by taking in the input of n for each test case. We'll take in the input of array, we'll store the position of each element inside this position array, and notice that all the elements are distinct, so it's one of them. We'll be storing the prefix minimum and the prefix maximum. We'll initialize the first element as well. For I equal to n, we'll store the prefix maximum and the prefix minimums. Now, if the position is equal to either the prefix maximum of m or the prefix minimum of m, for any m in between 1 and n, we'll add m minus 1 to our answer. Our answer is initialized to n. And in that, we'll be printing answer module. That's it. Now let's see the solution in Python. So we'll be running this function solve for all the inputs, all the test cases. We'll be taking in the input. We'll define the position array. We'll set the position of each array of ISI. And notice that all the elements are distinct. So this is one of them. Now we'll define this prefix max and prefix min arrays and we'll store that first. We'll initialize our answer as n. We'll run a loop of m from 1 to m. Now, if the position of this element is equal to either the right hand point or the left hand point out of the remaining elements, we'll be adding m minus 1 to our answer, and in the end, we'll be printing answer what you want. And that is it for this video. I hope you liked it. Thanks.